This is a sample problem of converting from moles of one substance to mass of another, or for that matter, from mass of one substance to moles of another. We're going to do one sample problem, and we're going to do problem number 10. If a plant produces 45.0 grams of glucose, how many moles of carbon dioxide were consumed? And notice that the answer is given. Now on your page, this balanced equation was not balanced. I've actually put in the coefficients of the balanced equation already. If you need help learning how to balance equations, you should let me know so I can get you sample problems to work from. All right, so solving this problem, the first thing we're going to do is take that 45 grams of glucose and write that as a fraction over 1. So you'll notice that I've written that as 45 grams of glucose over 1 to get things started. Now, in order to be able to convert from one substance to another substance, these coefficients from the balanced equation have units of either moles or molecules or particles of some type. These coefficients from the balanced equation are not in units of mass. They are in units of moles. So before I can even start using these grams in this particular problem, I have to convert it into moles to be able to use this balanced equation. In order to convert from grams of glucose into moles of glucose, I need the molar mass. When adding up 12 hydrogens, 6 carbons, and 6 oxygens, you should get a molar mass of approximately 180.18 grams of C6H12O6 for every 1 mole of C6H12O6. If I were to stop my calculation at this point, I would have moles of glucose as my current answer. It's not what I'm looking for. I am looking for moles of carbon dioxide, so how much carbon dioxide is going to be consumed. So in order to do that, I'm going to use the mole-to-mole relationship from the balanced equation. Right now I have moles of C6H12O6 on top, which means in the next fraction I'm going to need to put the moles of C6H12O6 on the bottom. So the glucose moles needs to be on the bottom. It'll have 1 mole of that. On the top will be 6 moles of carbon dioxide, because again, that's what's from the balanced equation. 6 moles of carbon dioxide for every 1 mole of C6H12O6. And at this point, if we look, the units will cancel for moles of C6H12O6. The grams of C6H12O6 cancel as well. And we're left with moles of CO2. That's when you're going to break out your calculator. When you break out the calculator, you should end with an answer of approximately 1.50 moles of CO2.